Hello, once again. How are you? My name's Andrew Dunkley, and welcome to episode 242 of Space Nuts, the podcast. And joining me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Andrew. What's with this "who are we" stuff? I mean, don't tell me you've suddenly developed a concern for our listeners.
It's just, I think it just sort of, I've just come off a radio shift, and I was still in
mode,
live radio mode. I think when that popped
That's
out.
All right. No, it's a nice
that's my excuse. Yeah. Well, I hope everybody's well. It would be would be sad if someone wasn't. Absolutely. But if there are people who are laid up in bed for one reason or another that are listening to our podcast, I hope we can bring them a little bit of pleasure and knowledge at the same time. Now, Fred, on this week's edition, we're going to just do a bit of a follow-up on the Perseverance Rover's landing on Mars. And some really fascinating stories this week. Old research has been given a new lease on life, literally, because it might give us clues about how to find extraterrestrials. I personally thought they'd just turn up and say, "Hi, I'm an extraterrestrial. Great to be here.
How are you?
When's the next bus?" How are you? Yes. We're also going to be looking at Boson stars. Basically, this is a story where gravitational waves may not be telling us the truth. I was always suspicious about them. And audience questions as well about neutron stars and checking the water signature on Mars. So yeah, it's a real jam-packed program this week on Space Nuts. But let's get straight into it and go back to Mars, Fred, where Perseverance is still hitting the headlines pretty hard. It's a popular topic, and not surprisingly.
Well, that's right. We've got this marvelous machine sitting on the surface of Mars that seems to be working perfectly. It's doing all that I think its mission scientists hoped it would so far. The reason why I just wanted to mention it, Andrew, is that I think it was last week, NASA released a 360-degree composite image of the surroundings of Perseverance. So it's a panorama, really quite high resolution. You can find it on various websites. Just look for Mars panorama, Perseverance probably. And what they do is they basically have a mast with the cameras and other equipment on it, and they can turn that through 360 degrees. And essentially, they've got one of the cameras is called Mastcam Z, or Z, sorry for our American listeners, and that captures the image. So what they've sent is this thing from, it's 142 photos stitched together. And what it shows you is the rim of Jezero crater, which is where the spacecraft is. That looks a long, long way away. But also there's a cliff, which is it's basically the end of that ancient river delta that Perseverance has come to explore. So this is the target area, because that cliff face probably has layers of sediments in it, which we hope will show stromatolites, which are the fossilized remains of microbial mats. We find them here on Earth, and they're a very early form of life, perhaps going back 3.5 billion years. And that's when we think Mars was warm and wet. So hopefully it's going to show when Perseverance gets there and starts zapping it with its lasers, we should start seeing some results. The nice thing about the panorama, though, we don't want to spend too much time on it, best is for people to go and look at it, is that in the foreground, you can see details down to about 3 to 5 millimeters across, just little bits of pebbles and things. Whereas when you go to the slopes in the distance, it's 2 to 3 meters. So yeah, it's worth a look. Have a look, everybody.
Oh, it is. It is indeed. I had to smile at one of the stories in the popular press over the last week about the strange shaped rock that it's spotted. Yeah. and the memes were thick and fast after that about this strange rock. One I think suggesting that it was Marvin the Martian's hat.
There's always that. It's the our tendency towards pareidolia, which is the the name for when you see things, familiar shapes in unfamiliar territory. And there's even a name for things like bits of rock that look like hats and things of that sort. They're called mimetoliths, which is something that reminds us of, it's made of rock, that's the Lith on the end, and it reminds us of things.
Yeah, like the face on Mars.
Yeah, exactly.
The
that's
great
the best
face.
name. Yeah.
Which is just a rock formation, but from space it looks like a face staring back out at you. And
you can bet your life.
Been the subject of much speculation.
You can bet your life Perseverance will unleash a whole flood of these things. Unfortunately, it's the way of the world. That's all. We can live with that.
Indeed, it is. But lots to come with that mission, and we look forward to telling you some of the stories that come out of that particular landing and what Perseverance may well discover. Now, Fred, let's move on to this story about some old research that may well give us some ideas on how to find extraterrestrial life, assuming they just don't turn up on the doorstep of the White House and say, "G'day, we've taken over the world, you're out of a job." So how are we going to find them?
Well, there are two sort of branches to this. The SETI sort of program, which is listening for radio signals from extraterrestrial intelligences. There's really been nothing in the last 60 years apart from the WOW signal, and a signal that has caused some interest, which came from Parkes in 2019, which hasn't yet been. There hasn't been a scientific paper published on it yet, but there's a lot of interest on the net. It was of interest because the frequency changed, and also the other thing that was interesting was that the Parkes Radio Telescope in New South Wales was pointing towards Proxima Centauri, the nearest star, which we know has a planet going, at least one planet going around it. In fact, I think it's got two. The thing about the Parkes dish in the mode it was operating, though, is that it's got a field of view of about half the diameter of the moon. So it could easily be a background source or even a foreground source. And it doesn't necessarily have to come from extraterrestrial life. It's gone now. Like the WOW signal, it never turned up again. But people are interested in it. And actually all the people directly involved say there's a 99.9% certainty that it's radio frequency interference of some kind, but they haven't tracked it down yet. So the other way, and the way that interests optical astronomers like me, people who study the universe with visible light and infrared, is to look for what are usually called technosignatures in the atmospheres of planets. Now, there are kind of two levels of this. You can look for biomarkers, which are things in the atmospheres of planets that tell you that there might be life processes going on, and they include things like oxygen, actually, which is if it's out of balance with carbon dioxide, then you know that something's replenishing it, and that is probably going to be living organisms. That's
and of course the big one, Fred, the big one, bovine excrement. I mean, that's a telltale sign.
That's right. Well, we've got that on Mars, but we haven't seen any cows on Mars yet.
No.
Yeah.
Wouldn't they be mows?
There might be mows, yes.
Sorry.
Yes. That's something else altogether. In fact, our cat is an Arabian Mow. Have you ever heard of that? That's its breed.
No.
Yeah, it's the strangest cat you've ever come across, honestly. Anyway, that's another story.
Yeah.
We'll do a feature on the cat sometime.
Fair enough.
Pictures on the web, which you simply will not believe. Anyway, so the methane is indeed thought to be a biomarker because it actually is. It turns into hydrogen and carbon when you shine sunlight on it. So it's got to be being replenished. There is methane in the atmosphere of Mars, and we still don't know where it comes from. It could even be microbes under the surface. However, these are biomarkers, and what we're really talking about now is technomarkers or technosignatures, things that tell you that there is technology there. And the typical one that we might look for is industrial pollutants, things that are created only by industrial processes. So what's happened in this, and the reason why this is a bit of an old story revisited, is that people have a long time ago suggested nitrogen dioxide as one of the pollutants, because on Earth, most of it is produced by burning fossil fuels, whether on the roads in our cars or in our power stations or whatever. So nitrogen dioxide on Earth is very much the product of fossil fuels. However, it's not a unique technosignature, because it can also be caused by lightning or volcanic activity. Those two both also produce nitrogen dioxide. So actually, a lot of astrobiologists have thought of looking for more exotic things that really are only produced by industrial processes, like tetrafluoromethane or trichlorofluoromethane. These are things that are industrial pollutants. And there have been astrobiology papers which I've read that say that these would exist in detectable quantities in the atmosphere of an exoplanet. However, the idea of it being nitrogen dioxide is actually the one that has kind of caused a bit of attention recently. There's a paper published last month, actually, in the middle of last month, which came from Ravi Kopparapu, who's at NASA's Goddard Space Flight Center, Greenbelt, Maryland. And what he's saying is that in the lower atmosphere of Earth, it's the nitrogen dioxide from human activities that dominates, compared with the non-human sources like lightning and volcanoes. So they have suggested that if you can pick up nitrogen dioxide in the lower atmosphere of an exoplanet, then it could be, that could be the techno marker. So that's basically what this study is about. It's that they've really looked at it in detail, and it's, as they comment, this is the first time nitrogen dioxide has been examined as a possible technosignature, because it's always been, sort of brushed aside because of the fact that natural processes do cause it. So they've done a lot of computer modeling and tried to predict whether nitrogen dioxide pollution would produce a signature that's detectable with the telescopes that we have today and the future ones. And they've basically come, think that it's a fairly positive conclusion. I'm just reading from the press release. They found that for an Earth-like planet orbiting a sun-like star, a civilization producing the same amount of NO2, nitrogen dioxide, as ours could be detected up to about 30 light years away, with about 400 hours of observing time using a future large NASA telescope observing at visible wavelengths. That's a lot, but it's actually kind of similar to what was used in the Hubble Deep Field when those images were made a few years ago. So it's an interesting suggestion. But one of the things that I thought was rather striking is that if you've got stars, which we usually call them M dwarfs, these are cooler than the sun, they're smaller than the sun, but they're also far more common than the sun. They're the most common stars in our part of the galaxy. 75% or something of all stars in our part of the galaxy are these red dwarfs, we call them usually. They have a stronger signal of nitrogen dioxide. And that's because, or a planet, so let me put it this way, a planet around one of those stars would have a stronger signal. And it's because there's less ultraviolet light in the output of the star, and that tends to break down nitrogen dioxide into its oxygen and nitrogen components. So if you've got these cool dwarf stars, the red dwarfs, they tend not to break it down. So there will be more of it. And so it would be detectable, they say. So yeah, really interesting piece of work.
Although we're making one big assumption here, and that is that another civilization on another planet would be as filthy as we are. And it's possible that, there are all sorts of possibilities. If they're out there, they may not be advanced at all. Therefore, these signatures wouldn't be at any significant level, or they've done things better than us, and they've got a clean planet.
Absolutely. And all these things have to be taken into account when you're thinking about extraterrestrial life, and particularly extraterrestrial intelligence. I should fess up here, Andrew, that one of the reasons why I chose this story is that I've just finished the main text of my children's book, and the final chapter is about this whole issue of intelligent life in space, and why there probably isn't any, although I won't give the game away. But so detection of things like this is very much part and parcel of the material of the chapter, and it is what we're trying to do here is effectively project ourselves into a different regime, and the only thing we can really do with any certainty is say, well, this is what happened on Earth, so this is a possibility, at least, that this is what might happen on another planet. And yes, you're absolutely right. There might be civilizations who've recognized the benefits of nuclear power, nuclear fusion, even, for example, which is something we haven't achieved yet on Earth. So, but it's great stuff, and it shows how astrobiologists are thinking. Maybe one day we'll find that signature, and it will be featured on Space Nuts if we're still here.
Yes, indeed. Wouldn't that be great? Wouldn't that be an awesome find? Gee, you can. We can live in hope.
Yes, that's right.
We might find it on Mars.
Yeah, well, it could be great to find the source of that methane on Mars, and that if that turns out to be methanogenic organisms. Probably not cows, but more likely just the microbes that live inside cows. That would be fantastic. Yeah.
Would be incredible. You are listening to the Space Nuts podcast, episode 242, with Andrew Dunkley and Fred Watson.
Roger, you're loud and clear here also. Space Nuts.
This is the Space Nuts podcast, heard on, dozens of podcasting platforms, whatever your favourite is. Thank you for listening to us every week. If you're a new discoverer of Space Nuts, welcome along. It is great to have you as a part of our little family, which is indeed growing. And I sent you an email the other day, Fred, and I just want to read this out. This comes from Dustin in Knoxville, Tennessee. Recently discovered the podcast and now look forward to seeing a new episode appear every week. Must be watching on YouTube. As a space nut, as well as a history buff, Episode 241 was a treat. That was last week. You guys highlighted a connection between astronomy and the French Revolution, and that's one of the many reasons I'm such a fan of your work. I appreciate you both and the service you provide to humanity. Well, that was lovely. Thank you so much, Dustin. I usually take the mickey out of comments because, self-deprecation is my favourite hobby. But, I appreciate the effort you've gone to let us know what you think, and that is fabulous feedback. And because a lot of the time we don't know what people think, and it's nice to get feedback like that. We get a lot of feedback on the Facebook Space Nuts podcast group, which is also a growing entity. It's a self-perpetuating group of Space Nuts listeners who get together to discuss things. One of the topics of discussion at the moment is it's this video that's been released about all the missions in space being fake, and I think the video shows people doing spacewalks and what appear to be bubbles in the water floating away from them. And that's basically created quite a few issues and comments amongst people. But it's a fun group, and if you would like to be a part of it, just look for Space Nuts Podcast Group on your Facebook search engine and join the group and have some fun and talk to each other, because that's what it's all about. Of course, we do have an official Space Nuts Facebook page as well, and you're more than welcome to join that as well. A lot of people send questions to us via Facebook, and that's fine as well. Now, Fred, we are going to now look at this research, this rather strange issue surrounding large gravitational wave detection. Because there's a possibility, according to this latest data, that these gravitational waves are telling us fibs. They're not actually indicating what we thought they were indicating, or not all of them, or maybe none of them. Who knows? What's going on?
It's not all of them. I mean, I think most gravitational wave detections of things like colliding black holes and colliding neutron stars, I think they're secure. I think they're so well modeled that they fit the bill exactly, and they fit all our understanding of what black holes might be like, and what constitutes a black hole. So I think, generally speaking, gravitational wave astronomy is in good shape, and we're discovering things fairly regularly. However, one in particular has raised some questions, and it's all about the mass of the objects that we think are involved. So this is a gravitational wave signal that occurred on the 21st of May 2019, and it comes from a distance of 7 billion light years away. It's, this is really in the depths of the universe. So we're looking back more than half the age of the universe when you look back 7 billion light years. And so it was a massive collision, and the detectors gave a very strong signal. And you'll remember that what happens when black holes collide is that they approach each other. They're basically in orbit around one another, and that orbit spirals inwards as they eventually coalesce. And it's the spiraling inwards that gives you this characteristic chirp in the gravitational wave signal. I've got to do it, haven't I? That's the way it goes. And where you get to the end, that's when the two have coalesced, and essentially they've formed a black hole which no longer gives a gravitational wave signal because it's not being accelerated. That's the whole point. So this event in May 2019, the calculation, the analysis of that signal let the astronomers determine what size of objects we're talking about here. And it was two black holes, one at 66 solar masses and one at 85 solar masses, 85 times the mass of the sun. And the reason why this is now in the news is that there's been a reanalysis, more of a different interpretation of what these black holes might have been. And it's an international team of very notable astrophysicists. So the suggestion is that these were not actually black holes, but theoretical objects, which are called boson stars. And now bosons are the subatomic particles that carry force, like the Higgs boson. That's the thing that gives us the mass. The photons are actually bosons, the subatomic particles that are transmitting you and me around the universe at the moment by electromagnetism. So I have not come across boson stars before, I have to say, and this interested me greatly because it could be a new form of matter. But the astrophysicists involved believe that some of the if you do have boson stars, what they could be made of would be something that is the same stuff as dark matter, whatever it is that's invisible in the universe, that's holding galaxies together and holding galaxy clusters together.
Yeah, you took the words right out of my mouth there. I was going to walk that path. I was going to bring up the dark matter question. Well, if I didn't, somebody in the audience would have.
Should rewind backwards. And then you say it again. Anyway, yes, they would. I'm sorry about that, Andrew.
Oh, no, that's fine. Glad you said it. So if that's the case, it could answer a lot of questions, could it not?
Yes. If it exists, I suspect it's going to raise more questions than it answers, though. But you're right. So what comes out of this is a black hole with a mass of 142 times the sun's mass, and that's it's getting on for what we call an intermediate mass black hole, which is where there's a gap. There's a sort of gap in the black hole range between the stellar mass ones and the supermassive ones. And there's not much in between. There have been a few candidates, but it's not much. And so 142 times the mass of the sun is getting on that way. But the reason why this work has cast doubt on whether it's black holes or not is that a black hole of 85 solar masses shouldn't exist. Because if you're assuming that the two candidate black holes, the two that collided, if, as we believe most of these small black holes do, if they come from the detonation of a single star at the end of its life, a supernova explosion, there is a limit on how big a supernova explosion you can have that will form a black hole. And if you've got one over about 65 solar masses, a single star of that, actually much higher mass to start with, because it's blown away a lot of its outer material, but something over 65 solar masses, it can't collapse to a black hole. And it's because, and I'm not a supernova expert, but I've heard of these things. They are called pair instability supernovae. A star in that mass range over 65 solar masses, it produces a pair instability supernova. And what it does is completely obliterates the center of the star, the core of the star, which is what in a normal supernova explosion, that's what collapses to the black hole, is the core of the star.
Yeah.
But apparently in a pair instability supernova, the whole thing's blasted to pieces. So you don't get anything left behind. And so you shouldn't be able to find black holes more than 65 solar masses. And here is one that is being postulated as an 85 solar mass black hole. Now, it is possible that that black hole got to its size by merging with another one. So it might have been two stellar mass black holes that merged and formed one of 85 solar masses. And I don't know what, I assume the authors have dealt with that. I haven't actually looked at the paper in detail. But if you assume that this, here we are, further down the page, it's possible that the black hole was the product of an earlier merger between two smaller black holes. That's kind of what my first thought was. But the other thing is that, and it comes from Spanish researchers actually, Juan Calderón Bustillo of the Galician Institute of High Energy Physics in Spain. They've looked at this possibility of these boson stars, and they say that it would match the numbers. So one of the other astronomers, José Font, I love this, University of Valencia in Spain, he says, our results show that the two scenarios are almost indistinguishable given the data, although the exotic boson star hypothesis is slightly preferred. What he means by the two scenarios is the pair of black holes or the pair of boson stars. And the theoretical look at these boson stars actually is slightly preserved. He goes on to say, this is very exciting, since our boson star model is, as of now, very limited and subject to major improvements. In other words, we don't really know what they're dealing with here. A more evolved model, that means with all more fancy bells and whistles on the theoretical model, a more evolved model may lead to even larger evidence for this scenario and would also allow us to study previous gravitational wave observations under the boson star assumption. And in the press release, it goes on to say there are boson stars at the moment purely theoretical and have never been detected before, but they are of increasing interest to astronomers, particularly in the search for dark matter. It
fascinating. Yeah, and I come across a description of what a boson star might look like, and they basically are suggesting they'll look a lot like a black hole except for one thing, and that is that they don't have an absorbing surface.
Yes.
That would stop photons or an event horizon, so they would actually appear totally transparent, which is it's mind-boggling. And they go on to say they're basically compact blobs of Bose-Einstein condensate in space.
Yes, which is really interesting, and that kind of makes a bit more sense of it, because a Bose-Einstein condensate is basically matter that is it's sort of compressed to a level where it behaves like a single quantum object. And quantum objects are weird, and we usually think of them as being tiny microscopic scale objects. But here's a star that might be a single quantum object, which raises all kinds of possibilities because quantum objects can be in two places at the same time. And maybe these Bose-Einstein condensates could be as well. It's great stuff.
We'll see. There's now the answer to long-haul space travel in no time.
Right. Yeah. Find yourself a friendly boson star and hook yourself to it, and there it goes.
Yeah. Actually, I think in the movie Interstellar, they portray an image like it's a gate to another galaxy, but it appears like that description, like a boson star, just a big blob of clear matter. It's fascinating. Yeah. Whoever did that movie, and I'll have to look it up again. It was very clever in putting theories into practice.
That's right. They had his name's gone, as they always do. Very, very well known.
Yeah, I know. I can't think of it either.
Relativist whose name will probably come to me halfway through the next segment, Andrew. Kip Thorne. Kip Thorne was the man who provided the the technical input to that. And yes, that means it was very well thought through. That's right.
Indeed. Yeah. So I suppose, I guess finding a boson star is as easy as finding black holes, and and we just as it says, it's purely theoretical, but it's starting to sound like there might be a little bit behind it. There might be something to it. So,
I think as you said, I think we're going to hear a lot more about these things. So, folks, remember where you heard it first on Space Nuts. Well, in the movie as well.
Well, it's in that paper, but we were telling you about it. No one else will bother. Oh dear. But hopefully there will be more to talk about in terms of boson stars in the future. We're not stars, we're just space nuts. And thank you for listening or watching us. This is episode 242 of the Space Nuts podcast.
Okay, we checked all 4 systems and keying was a go.
Space Nuts.
Thanks for joining us on the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson. And thanks to our patrons, there are many, and the list is growing. We appreciate your financial support. Of course, we are looking to ultimately make Space Nuts 100% reliant on patrons, so that we are not reliant on commercial enterprise, I suppose, commercials in general. Now, that's going to take a lot of patrons, and if you would like to sign up as a patron, go to our website, spacenutspodcast.com. Up in the top right-hand corner, there's a Support Space Nuts button. Click on that, and all the options are there for you to check out, whether it's PayPal, Supercast, Patreon, whatever form you wish to pursue is available to you there. Now, it's optional. As we've mentioned many times, you don't have to do this, but a lot of people choose to, and we are thankful for that because it puts a bit of money in the kitty, keeps us going, enables us to continue to spread the word about Space Nuts and grow our audience, which we like to do. That sometimes costs money. Isn't it interesting how the internet was made for all and sundry to keep the world communicating in times of disaster, and then someone said, "Hey, we can make money out of this."
Exactly.
And so it came to be. But yes, if you would like to become a patron, we would be so very grateful. But it's your choice, and you can find out more about it on our website. Now, Fred, we have some questions from the audience, and I think we'll just get straight into them and see what people are thinking about this week.
Hi, Fred. Hi, Andrew. It's David from Montreal, and today I got a question about strange matter. So I was looking at a video on YouTube about possible ends of the world on a channel called Kurzgesagt, and usually they're pretty good, so it's trustworthy. And they made some statements that I couldn't verify anywhere, so I'd like to have your input. So they were saying that strange matter, which is supposed to exist in neutron stars, I don't know if that's fact or just a theory. Well, they said it was so stable that even if you were to put the strange matter out of its neutron star, let's say after a collision, it would remain as strange matter because it's so stable. And they were saying that it's also so stable that if any other type of matter would come into contact with strange matter, it would kind of transform it into strange matter as well. So I couldn't verify this anywhere else. And the link with the end of the world is that they were saying that if a single droplet of strange matter were to fall onto the sun, well, the whole sun would transform into strange matter, hence beginning the end of the world. So I would really like to have some input about strange matter in general and maybe this topic specifically. So thanks a lot, guys.
Yeah, wow. That is odd. I think if strange matter did turn our sun into strange matter, that would be the end of the world. That would be my theory. But I've never heard of this before. What is strange matter? Aside from space nuts.
Yeah, that's right. Excuse me. We've got plenty of strangeness on space nuts, as I think we've just demonstrated there. Let me just do the honourable thing and read straight from Wikipedia. Strange matter, or strange quark matter, is quark matter containing strange quarks. There you go. That's it in a nutshell. Let me stop there, because quarks are the building blocks. They're one of the 17 subatomic particles in the standard model, and these are the ones that cannot be, broken into anything smaller. We used to think it was protons and neutrons, but actually they're made of quarks. They fall into a group of subatomic particles which we call fermions. And fermions are different from bosons, which we've just been talking about, Andrew, because bosons are the force carriers, and fermions are the matter carriers, principally. The fermions are divided into quarks and leptons. We don't really need to know about leptons, except that the electron's one of them. So that's a different branch. But the quarks, there are 6 quarks in the standard model, and they've all been revealed by subatomic particle physicists doing their thing with their atom smashers, and they've got really quite entertaining names. The 6 quarks are called up, down, charm, strange, top, and bottom. So a strange quark is one of them. It's just one brand of these quarks, right? So that's step 1.
Right. So I have heard of them. I just didn't make the
that's
connection.
right. No, that's right. And you don't, because when you talk about strange matter, you forget that actually what we're talking about is something that we probably understand reasonably well. But whether it can exist independently, I mean, we normally think of quarks as making up the other particles that we're familiar with, like the protons and neutrons and things of that sort. But to think of them on their own is interesting. Let me carry on with the Wikipedia definition, and I'm a great fan of Wikipedia, and I support them whenever I can with a donation, because they do a pretty good job, I think. In nature, strange matter is hypothesized to occur in the core of neutron stars, or more speculatively, as isolated droplets that may vary in size from femtometers, they're very small, to kilometers, as in the hypothetical strange stars. At high enough density, strange matter is expected to be color superconducting. I had a look at this yesterday, and I still don't understand what color superconducting is. And if I find out, I'll let you know. But so going back now to David's question, and thank you very much, David, for asking it, because it takes me well outside my comfort zone, and I need to do that from time to time. I honestly don't know the answer to what you have said. Maybe that website, the channel that you were watching, is on the money with it. That strange matter, a droplet of it could transform everything into strange matter. I'd need to research that a little bit further to find out whether it's the case. It would not surprise me. We have other instances in nature where bad things happen, like if you introduce a particle to its antiparticle, which has the opposite electrical charge, an electron and a positron, for example. You bring them together, they mutually annihilate. and you get gamma rays, you get bosons coming off them. And it's thought that the universe, when it kicked off, was equal in matter and antimatter, or nearly equal, and it all annihilated, and we just got an excess of normal matter. But there's people, some astrophysicists suspect that that there are pockets of antimatter still remaining in the universe, and if they get near matter, then you're going to get something fairly spectacular happening. So what you don't want is an antimatter sun coming anywhere near our real sun, or else you get the same thing happening.
No.
So that's a waffly answer to the question. A very interesting one, and I will look at it further, and I'll certainly let you know, David, if we hear any more about that. But what an interesting thing. Today we've touched on two still theoretical concepts, but quite different concepts for the insides of stars. Boson stars are a completely new stellar denizen, whereas strange matter stars, that they might, neutron stars might all have strange matter in their insides. We don't know, but it's a possibility.
Yeah, may well be. Thank you, David, and hope all is well in Montreal. Let's move on to our next question. Unfortunately, we don't know who, but I'm going to guess this is an Australian.
Hello, Andrew and Fred and Andrew. From what you were saying about Mars and the water on the latest episode, I'm wondering if there's any way we can check the signature of water under the South Pole that currently exists and see what the proportions of heavy water to normal water are, and compare that with what is in the Earth's oceans today. And I think this might be a way of checking to see whether the late heavy bombardment theory of the Earth obtaining most of its water, whether that still holds up. Thanks for an inspiring and very thought-provoking show. Cheers, guys.
Sounds suspiciously like Rusty from Donnybrook.
Do you think so?
I do. I hope it was. I hate to misidentify someone, but if it was you, Rusty, it does sound like one of his insightful questions.
It does, but it could be Gerald from Melbourne, or
it could be anybody. Yes.
Look, it could be anybody.
But I've got a good ear for voices. I think.
Do as a. Oops, sorry, my computer fell off its stand there. As a professional broadcaster, which I'm clearly not, you do have a good ear for voices.
I don't sell yourself short. You've been doing this for a long time. You're very experienced, Fred.
But it's a great question, and given that it comes from someone who's clearly in Australia, it's possible that said person might have watched the Catalyst special on the ABC last night, which had two mates of mine, Tamara Davis and Craig Quick, looking at the prospects of life on Mars. And in fact, one of their guests, and I'm very sorry that I can't remember her name offhand, I think she's based at the University of Southern Queensland, is one of the scientists who's done this work with the Mars Express spacecraft, which is flown by ESA. That's the spacecraft that was used to detect the bodies of water under the southern polar ice cap on Mars by ground penetrating radars. Great stuff. MARSIS, the name of their ground penetrating radar system. So she's the person to ask this question of. It was lovely to put a face to the name of the discoverers there. But the question really goes to the heart of what we want to know about these things. When you look at the history of water in the solar system, we've got this dichotomy between the water on Earth and the water that we commonly can detect in comets, which have different proportions of heavy water to normal water. It's the isotope ratios of heavy hydrogen and normal hydrogen. That's exactly what our anonymous questioner is talking about. And that's one of the reasons why, because there is this dichotomy, it's one of the reasons why, to some extent, the idea of the Earth's oceans being populated by water from comets and perhaps asteroids, which also contain water locked up in their rocks. That is why it's had some doubt cast on it. And commensurate with that has been the growth of the idea, and I looked at a paper on this only a couple of days ago, that actually there is enough water locked up in the rocks of the early Earth that could be released, and there was a suggestion for the mechanism that might do that. Unfortunately, I was, not taking too much notice of that paper. I read through it, but didn't go in and stay there. But there is clearly a mechanism that could generate the water on Earth from literally the water locked up in the rocks of the infant Earth. And so the question about Mars, the question that this anonymous questioner has raised, is right on the money. Because wouldn't it be great to have a prod of that water under the South Polar ice cap and see what its isotopic ratio is, what proportion of heavy water to normal water we're looking at? Yes, the question is there any way of doing it? Well, there is. Sending a spacecraft there and drilling holes, I think it's about 4 kilometres under the ice. Very much the kind of thing that's been done in Antarctica. And without, of course, taking any earthly bacteria there to pollute whatever might be living in that water underneath the ice cap. That, I think, is a long way off at the moment. I think experiments like that are still more than a decade, maybe more than 2 decades down the track, but it is a fascinating thing to want to do. I believe, from a position of relative ignorance on this, but I think that will be the only way of doing it, to sample the water directly rather than, do it by remote sensing through the ice. I don't believe that will be possible, although I would be happy to be proved wrong on that. There might be astrobiologists who could say, oh no, you can look at there's a temperature gradient that you get that's different from one sort of water to another. I don't know the answer to that, but a great question though, and one that I'm delighted to have talked about.
Why wouldn't we be able to just sample water from an easier source on Mars and do a comparison with that? Is it different?
No, that's an excellent question, Andrew, and it may well be that I would assume, and you kind of put your finger on it there, I would assume that another way would be to sample the ice itself, which is mixed with carbon dioxide ice, but is mostly water ice. Now, then you've got to make the assumption of whether that body of liquid water is the same stuff. But it is a pretty obvious assumption, which I'm very embarrassed that I didn't think of before.
Well, no, it just came to mind, and it made me wonder why go to all that trouble of digging a hole 4 kilometres down when there's water just there. Well, it could be the same stuff. But then again, it might not be.
There are times when the bleeding obvious is actually is not so perceptible to the likes of me.
It reminds me of a documentary once that I watched as a kid about this gold prospector in the United States who spent his entire life looking for this one big, lucky find to become the rich man he never became. And the irony was that he, in his wanderings, he found these black rocks and tossed them away. And it turned out later that they were in fact, or did in fact contain gold. And I've never forgotten that story about, it was right there in front of him and he ignored it.
That's what would happen to me if I went to Mars.
Did it the hard way and never got rich.
I'd be drilling holes until you tapped me on the shoulder and said, why don't you melt this?
Yeah. Did you know, I didn't know this until someone on Instagram brought it to my attention, that you can actually apply for a boarding pass for a mission to Mars? Did you know you can do that?
From who?
From NASA.
Okay, good. Right.
I think we ought to do that.
Should.
I don't think we'll get a seat.
We should take our spades with us to dig up the ice and ask to be dropped off on the southern ice cap.
And that same person I want to say thank you to for doing such a wonderful review on my audio book, The Turanian Enigma. She goes by the name of the Parisian Panda on Instagram, and she's she's done me this wonderful favour, and she's a lovely lady and a very good singer too. I've watched some of her videos, and it was delightful for her to do that, because she didn't have to, and she's listened to the audio book and done this nice little review on Instagram for me. Good. So that's terrific. So thank you so much for doing that, and thanks for giving us the tip about the NASA Mars boarding pass. I didn't know that was a thing, but it could be a lot of fun. Fred, we're going to wrap it up. Thanks to our inquisitive listeners who sent in questions. Don't forget you can too via our website. Just go to spacenutspodcast.com, click on the AMA link. Now you can send us a text version of your question through the email interface, or you can do the audio thing. Both of those questions came through with excellent audio quality. So, obviously they've got much better gear than I've got. I mean, I just got this clunky old thing here, but and a set of car keys. But other than that, good job. So, and don't forget to tell us who you are, Russell. I think it was. And apologies if I'm wrong.
That's right.
I'll get an email now for sure. But thanks, Fred. It's always good fun. Nice to see you. We'll catch up with you next week, I hope.
That sounds good, Andrew. I'll try and be more wide awake next week to the possibilities with ice and wheels.
I am never wide awake. Breakfast radio takes it out of you. It's actually, the worst part about being an Eastern Seaboard breakfast radio presenter in Australia, the worst thing is? I actually live on New Zealand time.
Yes, you would. Yeah,
that's the way it works. I am just sort of shifted 3 hours to the east by order of my shift times. It's a permanent jet lag.
Yeah, you would be. Yeah. Well, it doesn't.
And I just get out of it on a Sunday morning, and then I've got to go back on Monday.
I have to say. You do an extraordinary job of getting up early. Astronomers are not morning people, I have to say.
I guess not.
So that's the way it goes.
Yeah. Well, I've been doing it for 27 years now. Yeah. Getting up at the crack of dawn. So
well done.
I'll get used to it one day.
It doesn't look as though it's done you any harm.
You want to bet? I'm 25 years old.
That's right. Yes, I forgot that. Yeah. So am I, actually.
Yes, that's what I'm saying. All right, Fred. Nice to talk to you. We'll catch you again next week. Thank you. Bye-bye. Fred Watson, astronomer at large, part of the team here at the Space Nuts podcast, and thanks to Hugh in the studio for pushing all the buttons and making all the bells and whistles do what they're supposed to do. And from me, Andrew Dunkley, thanks again. See you next week. Bye for now.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.